Hi friends, we have already discussed working of single phase off wave rectifier. In this video, let us discuss how to find the output voltages. Okay, average output voltage and average output current, average RMS output voltage and RMS output current. Let us discuss all these four things so we can move forward. So I have taken the waveform of the waveform that what I have used for the explanation of single phase off wave rectifier for continuity, and based on this waveform only we need to go ahead. So here output voltage is like this. So this third waveform is the output voltage waveform. So if you can see, the thyristor will conduct from alpha to pi. After that, from pi to 2 pi it is not in conduction, so the output voltage is 0. After 2 pi plus alpha also, up to 2 pi plus alpha, the thyristor is not in conduction. So what will happen? So this comes under one complete cycle. So I can take the cycle here. If you cleanly observe, the waveform from 0 to 2 pi is repeating in this particular waveform. Okay, so I can say that the cycle is from 0 to 2 pi and the time period is 2 pi. Okay, so now I can go ahead with the calculation part of average output voltage. So first of all, we should know what is formula for average output voltage. The average output voltage formula is 1 by time period integral 0 to time period f of t and dt. So here f of t is this waveform. So complete waveform, this sine wave, whatever the sine waveform is there, so that complete waveform we have to follow. So let us move forward. As we discussed, time period t is where time period t will be equal to 2 pi. This part we have just now seen. So 1 by 2 pi integral 0 to 2 pi f of t means Vm sin omega t, dt means d omega t. So this will be equal to 1 by 2 pi from 0 to 2 pi Vm sin omega t. So my output voltage is, every time it is following the input voltage source. So that's why whatever input voltage input voltage function is there, I have taken that same function here. Okay, no problem, we can take like that. But it is running from 0 to 2 pi, but in 0 to 2 pi span, in many places my voltage is becoming 0. So it is appearing only from alpha to pi. So I can directly take that value from alpha to pi only, alpha to pi Vm sin omega t d omega t. So which is equal to 1 by 2 pi. Vm is a constant, so I can take it out of the integration, and integration of sin omega t will be minus cos omega t, and the limits application is from alpha to pi. So this will become Vm by 2 pi into minus cos pi minus of minus plus cos alpha. So this will be finally becoming Vm by 2 pi into cos pi value is minus 1. So minus of minus 1 will give us plus 1. So Vm by 2 pi into 1 plus cos alpha. So this is the average output voltage of off wave rectifier. That's all. Now let's move on to the RMS voltage. Of course, I can write one more thing for average output current. As we are using only resistive load, so the current will follow the voltage. So average output current will be equal to V naught average divided by R. So which can be equal to Vm by 2 pi R into 1 plus cos alpha. So this is the average output current. Okay, now let's move on to the RMS output voltage and RMS current. Now let us solve RMS output voltage. So first the formula is like this: V naught RMS is equal to square root of square root of 1 by t integral 0 to t f square of t dt. So according to this, if I substitute all the values, I will get like this: 1 by 2 pi integral 0 to 2 pi f square of t means Vm square sine square omega t d omega t, which is equal to Vm square is a constant, so let me take out of this integration. So let us keep everything within this square. Okay, at the end we will take it out. So it should be Vm square by 2 pi, and sine square can be converted. Okay, let me write that step here. So it is 0 to 2 pi 1 minus cos 2 omega t divided by 2, and this is with d omega t. Now it will be very easy, is equal to, let me take square root only, square root of Vm square divided by 2 pi 1 by 2. Okay, so 1 by 2 means it's a constant, take it out, and this is half integral of nothing is there, so 1 d omega t. So 1 d omega t means it will come as omega t. Let me write omega t from 0 to 2 pi, again 0 to alpha it is 0 and pi to 2 pi it is 0, so I can take only alpha to pi. So let me take it from alpha to pi, so the limits are alpha to pi, minus cos 2 omega t. So the integration of cos 2 omega t is sine 2 omega t divided by 2. Of course this 2 we have to take it out, so if I take the 2 out, it will be like this: 2 into 2 pi. Okay, so now this is the integration part, and it should be from alpha to pi. That's all. Now I need to substitute the values, lower limit and upper limit. So square root of Vm square by 4 pi, it is pi minus alpha minus sine 2 pi is 0. Okay, so first one is 0 and second one is sine 2 alpha by 2. So this is minus, while applying the limits, okay, upper limit minus lower limit, so with that one minus will come here, so minus plus minus will become plus. It should be sine 2 alpha by 2. That's all. So generally it will be written like this. So V naught RMS is equal to Vm by 2 root pi into pi minus alpha plus sine 2 alpha by 2 whole power 1 by 2. So this is V naught RMS. Okay, and coming to IRMS, that part is also, so I naught RMS is equal to, this is simple resistive load, so it is V naught RMS by R. So if I write R here, then it will be IRMS. Okay, so this is simple only. So like this we have discussed two voltages and two currents for output. Okay, one is average output voltage and average output current, RMS output voltage and RMS output current. So these are very important while solving the problems. Thank you so much for your careful listening, and if you like this video, please like it and kindly share it with your friends and family, and please subscribe to my YouTube channel. Thank you so much.